In this video, we're going to take a look at some problems that involve using trig in order to find some solutions. Unlike the problems that we've looked at, though, these questions will involve the use of two triangles in our computations. Because we're looking at two triangles, obviously the pictures are going to become a little bit more intricate and a little bit more complex. But I think it's easiest to deal with this if you get a set of highlighters and utilize some colors in your pictures. Let's go ahead and get right into the first one. If you haven't already, you do need your graphing calculator in order to complete this video. Number one says a firefighter on the ground sees the fire break through a window. The angle of elevation up to the windowsill is 32 degrees. The angle of elevation up to the top of the building is 40 degrees. They tell us that the firefighter is 72 feet away from the building, and they want to know what is the distance from the roof to the top of the windowsill. And then they're telling us what they want us to round to. So if we look specifically at what we're trying to find here, what they're asking us to determine is the distance from the roof to the windowsill. So the roof in the picture is here, windowsill right there. So that little distance that I just highlighted in red, I'm going to call X because that's what we're looking to find. Notice that all of the angle measures and segment measures that they gave to us in the problem, they also labeled for us very nicely in the picture. That's going to be helpful. The other thing I want you to notice about the picture is that in the picture there are actually three different triangles. We're going to focus only on the right triangles because we can only use trig right now for right triangles. So one of the right triangles is right there, and I just made that fellow blue. The other of the right triangles, the big right triangle, I'm going to make green. And one of the strategies my kids have found very helpful in the past, and we've talked about in the past, is to separate these two triangles. So I'm going to sketch the green one separately from the blue one and label all the dimensions in both triangles. So my green guy has his little right angle down here at the bottom. His height on the right side, I'm just going to call Z for right now. His hypotenuse is over here. You might label that with an H or an H1 for the first hypotenuse. His angle measure down here at the bottom is 40 degrees. And the length of the line segment down at the bottom, 72 feet. And then I'm going to do the same thing for the smaller blue one. So his hypotenuse I'm going to call H2. The height I'm going to call Y. Here's his right angle. This distance here, the 72 feet. And his angle down here at the bottom, 32 degrees. So really, if I could find the height of the green triangle, and if I could find the height of the blue triangle, I could subtract the two from each other, and then I would know the length of my red line segment, X. So that's kind of going to be my goal or my mission, is to find the height, Z, of the green triangle, find the height, Y, of the blue triangle, and subtract the two in order to determine that distance from the roof down to the windowsill. All right, so it doesn't make a difference which triangle you start out with. I think I'm going to start out with this big green fella. H represents my hypotenuse with respect to the 40-degree angle. Z is my opposite side. 72 is my adjacent side. So I need to use the trig function that deals with opposite and adjacent. So the trig function that I'm going to use to solve the green triangle, tangent. And I'll begin by writing that ratio down on my paper. Tangent is equal to the ratio between the opposite side and the hypotenuse. So the tangent of the angle that I'm working with, 40 degrees, is equal to the length of the leg opposite that angle, Z, over 72. And now I can go ahead and cross multiply. Z is equal to 72 times the tangent of 40 degrees. And if you would like to, you can use your calculator to punch in 72 times tangent of 40 degrees. Just remember that if you do that, you need to include in your computations the entire decimal display from your calculator. I'm going to go ahead and stop with that triangle for right now and move on to the blue triangle. In the blue triangle, I've already labeled my hypotenuse. And again, the side opposite, or the leg opposite the 32-degree angle, is Y. The leg adjacent to the 32-degree angle is A. So again, I want to use the trig ratio that deals with opposite and adjacent. So like the green triangle, the trig ratio that I need to use for this blue fella is also the tangent. So tangent of my angle, 32 degrees, is equal to the length of the leg opposite, which in this case I called y, and the leg adjacent, which is 72 degrees. So y is equal to 72 times the tangent of 32 degrees. And like in the first case, I could, if I wanted to, plug this into my calculator and come up with a numerical value. And if I do that, I need to make sure that I include the entire decimal display on my paper. If I go back to my picture, I notice that x is simply the length of this green fella subtract the length of the blue guy. So in other words, z subtract y. So what I'm going to do now is go into my calculator, and I'm going to use my calculator to do z, which is 72 times tangent of 40, subtract y, which is 72 times the tangent of 32. So I'm going to go ahead and dig my calculator out. You should do exactly the same. And once you dig your calculator out, you want to make sure, like always, that we are set to degrees and that we're set to display that float 12. So I'm just going to go and make sure that my settings are appropriate, and they are. So now I can go back home. I'm going to open up a new document. And then into that, I wanted to compute the value of 72 times the tangent of 40 degrees. And from that, I want to subtract 72 times the tangent of 32 degrees. And then I want to make sure that I read and follow directions. They're telling me in this particular question to round our answer to the nearest tenth of a foot. So when I round that answer to the nearest tenth of a foot, I end up with 15.4 feet. And I should here use my about equal to, because this is our rounded value. So my answer here, 15.4 feet. So these questions are a lot the same as what we've been doing. The really key thing here is that you have to make sure you separate the two triangles when you get started. And if you use your highlighters to do that, you're going to find that it's a much, much simpler process than if you don't try to separate the triangles or don't try to use your highlighters. Moving on to number 2, Jack and Jill, 20 meters apart. And again, they've labeled that for you nicely in the diagram. Jack sees the top of the building at 30-degree angle of elevation. Jill sees it at a 40-degree angle of elevation. And they want us to find the height of the building. So again, I'm going to use my highlighter to highlight the two right triangles. And again, we're only dealing with right triangles because that's the only kind of trig that we know how to do for right now. And I'm going to go ahead and draw these two guys separately. So this angle here, 30 degrees. Now, if this piece measures 20 and this piece measures x, the entire thing is going to be 20 plus x. And I don't want to confuse that with the leg of my right triangle, so I'm just going to go back and erase. But this guy here is 20 plus x, and the other leg we've called h. In the purple triangle, this guy is h, this guy is x, and angle 40 degrees. So again, I'm going to go label my parts with respect to that 30-degree angle. This guy's a hypotenuse, opposite, adjacent. So like the first example, the trig ratio that we want to deal with, opposite and adjacent, the tangent ratio. So tangent is the comparison between the opposite leg and the adjacent leg, meaning that the tangent of 30 degrees is equal to the opposite side, h, over the adjacent side, x plus 20. So this is a little different in that when we go to cross multiply in one direction, we find h, but in the other direction, we find our product is x plus 20 times the tangent of 30 degrees. Likewise, for the second triangle, this purple fella over here, here's my hypotenuse, which I'm going to label H2, opposite, adjacent. We want to use the trig ratio that deals with opposite and adjacent. So again, we want to look at the tangent ratio. In the purple triangle, the degree measure of the angle is 40, equals the length of the opposite leg, h, over the length of the adjacent leg, x. So h is equal to x times the tangent of 40 degrees. Okay, at this point we have this nice little system of equations where we have h that's equal to this expression, and we also have h that's equal to that expression. So what I'm going to do is go set the two of them equal to each other. So I've got the tangent of 30 degrees times x plus 20 is equal to the tangent of 40 degrees times x. And at this point, since I'm kind of at a loss to where to go in the equation, what I'm going to do is I'm going to get my calculator out and I'm going to write out the decimal display values for tangent of 30 degrees and tangent of 40 degrees. So on the left side of my equation, I'm going to go ahead and again approximate tangent of 30 degrees. And what I find is that decimal value is about equal to 0.577. But keep in mind that if I'm using a decimal value, I need to display the entire calculator display on my paper. So 0.577 times the quantity x plus 20. And then I'm going to do the same thing on the right side for this tangent of 40. And when I plug tangent of 40 into my calculator, I end up with 0.83, and then I need to make sure I include all of those decimals. On the left side of my equation, I'm going to go ahead and distribute, again including all of the decimals and the information that I display on my paper. When I multiply the 20 times the 0.577 number, I end up with 11. And again, I have to make sure I include all those decimals. So you'll have to work hard to keep your paper neat here. I'm going to go ahead, because I've got x on the left side of my equation and x on the right side of my equation, I'm going to go ahead and subtract the 0.577x from both sides. So on the left side, I'll still end up with that 11.54 number. But on the right side, when I do the subtraction, and I've got to make sure I put all those decimals into my calculator. I want to subtract this 0.577 number I have up here. So if I want to, I can go capture that number and pull him down, which will save you some work as you're entering decimals into the calculator. And again, we want to make sure that you include all of those decimals in your work. And this is times x. So now I'm going to go ahead and divide both sides by that 0.26 number. And again, you may already have the 11 number into your calculator. I have to take the time to go ahead and enter that. And I want to divide now both sides by that 0.0 or the 0.26 number. So again, I can reach up and highlight that and hit enter, and it'll drag it down to the next line for me. So now I've solved for the value of x. And the value of x is that number that I need to drag off my calculator. So 44. And at this point, I'm feeling like we've run a marathon and we should be near the finish line. And in fact, we are, although we're not quite there yet. We need to go back and make sure that we've asked or solved for what they've asked us to find in the question. And they've asked us to find the height of the building. We have, at this point, actually found x, which is this horizontal length between Jill and the building. However, I know that the height of the building is equal to the value I get for x times the tangent of 40 degrees. So even though I'm not quite there yet, I'm pretty close. I just need to go back to my calculator and I need to input that x, which is that 44 number. So I'm just going to go up there and grab that times the tangent of 40. And then once I do that, I'm going to go ahead and read carefully and make sure I round appropriately. And I'll be done with this question. So this, I don't know, it's not necessarily hard work. It's a lot of work in that you have a lot of decimals and a lot of numbers to write down on the paper, but it's not the most difficult work in the world. So they want us in this question to round to the nearest tenth. So to the nearest tenth, 37.0. Although it doesn't say here, I'm going to change this and make it round to the nearest tenth. So to the nearest tenth, 37.0 feet. So again, there's a lot of work to show for that question, a lot of decimals to display, but it's not a terribly difficult kind of question. All right, like always, I'm going to have you summarize the key takeaways and then see what you can do with, let's do just that question number 2 on the next page. I think that will be quite enough for today.